Next we need to talk about similar triangles. Similar triangles are defined by having equal angles and the ratios of their sides are equal. So I'm going to look at two triangles here. Triangle ACB, so that would be that's the big triangle here, the outside triangle ACB, and triangle EDB. And I'm going to say that triangle ACB and triangle EDB are similar. Okay, so let's look at the definition and see if they really are similar. Well, first of all, they have to have equal angles. Well, we know that angle C and angle D are both equal. They're both 90 degrees. We know that angle B is equal to itself because they both have angle B in them. So what about A and E? Well, A and E have to be also equal because if B and D and B and C are both equal, then whatever's left over has to be equal too. In other words, angle B plus angle D is some angle plus 90, and then subtract that from 180 and you get E. Some angle plus 90, subtract that from 180, you get A. It's the same angle. So A and E are also the same angle. So if they have equal angles, they are similar. Actually, the second part isn't really part of the definition. They just have to have all equal angles. If they all have equal angles, then the ratios of their sides will automatically be equal. So let's just take a look at that. Let's start with the smaller triangle. The smaller triangle has sides of 4 and 3, and you might recall from the Pythagorean theorem that this side would have to be 5. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. Okay, so that's called a Pythagorean triple. It's a special type of triangle. Now let's look at the outer triangle. So if we look at the outer triangle, which I'll outline in blue, this length here is 8. This is 6. 1, 2, 3, 4, 5, 6. And this has to be, this length here is 10. We have the same thing that happens. 6 squared plus 8 squared equals 10 squared. This is 36 plus 64 equals 100. So by the Pythagorean theorem, that also works for a right triangle. So notice that if we look at ratios of sides, if we look at the shorter side, so side AC, let me put this in blue and red just to distinguish this. So AC over CB is equal to 6 over 8. If we look at the red triangle and look at the two legs of the triangle, ED over DB is equal to 3 over 4. Well, 3 over 4 and 6 over 8 are both 0.75, so they're exactly the same ratio, 75%. 6 over 8 reduces to 3 over 4. We could pick another pair of angles. We could say that if we look at the ratio of the shorter leg to the hypotenuse, we would have AC, I'm going to do that in blue again, AC over the hypotenuse, AB, is equal to 6/10. If we look at the red triangle, we would have ED over EB, which would be 3/5, and 3/5 and 6/10 are equal to each other. So notice if their ratios are ratio of the sides are equal to each other, then their trig values must also be equal to each other. For example, if we look at sine of angle A is opposite, so opposite angle A would be 8 over hypotenuse, which is 10. Now if we look at angle E, which is supposed to be the same value, sine of angle E is equal to 4 over 5, which is the same as 8 over 10. Okay, they're the same angle, they have the same trig value, even though the sides of the triangles are not the same in both triangles. They're both still 0.8. 4/5, 8/10, they're both 0.8. If we looked at angle B, so let's just for example, cosine, now let's do tangent just for something different. Tangent of angle B using the bigger triangle would be opposite here over adjacent, so it would be 6/8. But if we look at tangent B using the red triangle, it would be 3/4. But we already talked about 3/4 and 6/8 are the same number. So we can see that the sides of the triangle, the lengths of the sides aren't what matter, it's the angle. So there's a couple summary statements that I want to make for you here. The first one, I'll kind of move this up here. Since trig values are the ratios of sides, similar triangles have the same trig values. Secondly, trig values depend only on the size of the angle, not on the length of the sides of the triangle. So if I can have two triangles with the same angle in it that I showed you before, angle B, for example, is in both triangles, it doesn't matter which triangle I use to find the tangent value, I'm going to get the same tangent value. So that's important to remember.